right, in CR2, we're looking to solve these equations. So sometimes we're going to solve, so we have really two ways to be able to solve them. We could do it from our factored form. And then what we do is we set our factors equal 0 because our equation will equal 0. Or we could do this from vertex form. And when we do that, we're just going to undo operations. So we're going to go backwards through our PEMDAS. All right, so this first one, we just see it in our standard form. So we could try to put it in factored form, or we could actually try to put it in vertex form. I'm going to put this in factored form, and also not all of them do factor, but we're going to look at this one to see if it does factor. It's an easier one to factor because we just have a 1x squared. So we'd split into x and x. And then we're looking to see what multiplies to be the -8 and adds to be 2. So it looks like a +4 and a -2 would multiply to be the -8 and add to be 2. So if I multiply this out, I would get x squared plus 2x minus 8. So then, as it says here, our factors are going to equal 0 in our equation. So x plus 4 equals 0. So we get x value of -4. And then x minus 2 equals 0. So we get a value of 2. These are our two values for x. All right, the next one. We really have to do the next one by factoring because it's not quadratic. We have this power of 3. But if I notice in every term, they all divide by x. So I'm going to take that x out first. It's that greatest common factor. And it reduces this power throughout. Then I want to factor this more. So I'm going to use a box for that since it's a little bit more of a challenging factor. So 2x squared, -28. When I multiply that together, I get -56x squared. So that's what it's going to multiply to be. And what it needs to add to be is that middle term of -x. So even that adding -x, I know that these numbers just have to be 1 apart. I could still make my list of 1 and 56, 2 and 28. I could see, does 3 go into this? It does not. 4 does go into 56 though. We have 4 and 14. 5 does not. 6 does not. 7 times 8 is 56 though. And then 8's already on our list, so we have found everything. I want my answer to be negative when I add, so I make my bigger one negative. And this is my combination that's going to give me a -1. So 7x and -8x. All right, so I looked at factor here. So horizontally here, I'm going to look at these two. They both have an x in common. And down here, they both have a -4 in common. Vertically, I look at this, or I also say x times what will give me 2x squared. That would be a 2x. We can also see there's 2x in common. Just like I can go x times what gives me 7x, that'd be 7. And I really just should make sure I'm getting those last boxes too, that it equals that -8x and that -28. So now my factors, I have an x, I have a 2x plus 7, and I have an x minus 4. I'm going to set each of those equal to 0. So this first one I get 0 from. Let's see, this is going to be a little tight here. So I get x equals 0. This is one answer. I'm going to do this 2x plus 7 over here to give myself a little bit of room. So I'm going to subtract the 7 and then divide by 2. So -7/2. And then if I set this one equal to 0, I'll add it. So whenever there's that coefficient in front, you're going to have a fraction. And you can leave it as a fraction. This one would equal -3.5. But if it's some kind of like decimal that keeps on continuing on, leave it in the fraction form. All right, the next one. Now this one we see it's in vertex form. So we're not going to have to do as much to set it up into one of these forms. So what we're going to focus on is undoing the operations. So we're going to take that PEMDAS and go backwards through this. So I'm going to look at any addition or subtraction I have to undo. And also, if you notice in this equation, you only see x in one place. So we're trying to get that x all alone. We would not want to FOIL this whole out, because also this might not factor. We might have decimals, and especially this kind of indicates we probably will have some decimals. So let's add the 66 to both sides. Then we're going to look to undo any multiplication or division. So we're going to divide by 2. Then we're going to undo any exponents. So we're going to square root both sides. So we'll have an x minus 5. Oops. And then here, we're going to get a decimal here. So square root of 33 on our calculator is 5.7, and I round it to 4. We're going to do 2, actually it says it's the nearest tenth, so 1 decimal place, so 5.7. But we do have to consider the positive and negative value here. So we can't forget that. That's how we're going to have 2 answers from that. So when I add 5, I'm going to have to add it to 2 different numbers. So I'm going to have a positive 5.7 that I'm adding 5 to, and I'm going to have a negative 5.7 I'm adding 5 to. So I'll get 10.7, and I'll get a negative 0.7. These are my 2 answers I have for it. You could check by plugging them back in. And it should be really close to 0. Okay, if it's not close to 0, you might have a sign error, or you might have some other operation error in there. Sometimes it's this 5 that people want to add 5 and subtract 5, and that's not where the plus or minus should go. So it's kind of it's wise to be able to go back and be able to check your answers, especially whenever you're solving. We could have done that back in number 10 and number 9 as well. We could plug those back in, and we'll make those equations equal to 0. Okay, we're going to try one more with that here. So again, we're going to undo the addition or subtraction, so we'll add the 36. Then we'll divide by 4. And then we're going to square root both sides. So x plus 1, and then we'll have a positive or negative 3. Okay, we got a really nice number, so that means if I would have put this in standard form, it would have factored. Okay, number 11 wouldn't have factored, so I don't have to worry about rounding at all. And so then when I subtract 1 here, it's going to be from a positive 3, I'm going to subtract 1, and a negative 3. So I get 2, and I get negative 4. So these are my answers. Again, I could plug them back in, and I could see if I'm getting 0 for that. Okay. So we're really looking at, again, focusing on putting into the factored form or the our vertex form. And sometimes factored form, we just might have a greatest common factor we have to factor out. If it's already in one of those forms, work with it.